Okay, so we all have a class today. We're gonna go ahead to move on to a new chapter. We're gonna talk about lipids. Okay, so lipids. Now basically we will mention the fatty acids and the triglycerides. So there is some of the opening remarks and some introduction. First of all, the definition. What is lipids? This is a very difficult to do. And if you look at all the textbook or the material, it is kind of confusing you, but the best definition is kind of surprise you will be chemical compounds can dissolve in organic solvents. So for example, you have alcohol, and you have like a chlorophyll, chlorophyll, and you have like a benzene, like these type of chemicals. Any of the chemical compounds can dissolve in the organic solvent. It is called lipids, but there is an exception. So people find that if you have a monoglycerides, the fatty acids, this one actually is not. It dissolved in water. So just want to let you know this is an exception. So except for monoglycerides fatty acids. So it's very interesting. And the short chain fatty acids, monoglycerides, short chain fatty acids. It's dissolved in the water. Okay, so when we talk about the lipids in a food products, we'll actually talk about oil. This is liquid status. And we talk about fat, which is in a solid status. Now, most of the lipids, when we talk about that, it is non-polar. So for example, you have a triglycerides, and then you have like a cholesterol, and these are not dissolved in the water, but you also have some of the polar lipids. Let's say phospholipids. So phospholipids, it do have two different sections. You know, it's a head, which is a hydrophilic, and the tail, which is hydrophobic, and we also call it a lipophilic. Okay, so this is something we talk about the characteristics. Now, what's their function? The function of the lipids, it's obviously very simple. You know, it's solidification, and it will be an interaction, and it will have an emulsification, and on, lots of other functions. Now, they contribute to the color, texture, nutrition value, and more important, it gives you energy. So these are very obviously, okay, some of the opening remarks. Now, if we want to categorize the lipids, we also can differentiate them into visible versus invisible. So in a food products, usually visible fatty acids or visible lipids is actually about like 40%. And 60% of them is invisible in the food products. So what are examples of the visible lipids? Taro, that is come from beef, cattle. Lard, which is coming from pork and pig. And then you have some of the manufactured products called margarine, and have some shortenings. So these are some examples you will see the fatty acids here and the lipids here. But there's also invisible, that's variously in all kinds of products. Okay, even there's a trace amount in the fruits and the vegetables. So this is some categorization. Now we also could categorize the lipids into a different resource. We can say it's have animal lipids. Animal lipids. And we have some plant lipids. So animal lipids, we have so we call it a depot fat. So that we just mentioned, like lard, like taro. We could have some of the milk fat. The fat coming from the milk products. That's a whole milk, 8% fat there. That is coming from is a microorganism or microbiomes in the cow ruminant. So that's why we have a whole topic called ruminant nutrition. It's interacted with microorganisms. The last one, we have some of the marine fat. Marine fat. What are they? So they call it EPA, DHA, or it's a major component in the fish oil. But by the way, it's very interesting. What are these two stuff? We're going to mention this. Very interesting stuff. What is EPA? So-called penta-ionic. Okay, what is DHA? Decosa-hexo-ionic. Okay, what is this one called? C20, 4 delta, 5 delta 4. This is 22, 6 delta 5. Okay, so what is that? This is cis, start from 5, 8, 11, 14, and 17. Is that right? Sorry, 5, 5. How about that one? 26 delta 4. This is delta 4. And this is coming from cis. We go 4, 7, 11, 14, 17, and have another one, it's 20. Sometimes this is 19. Okay, each is 3 distance. So we'll mention about this real quick. And this is, we also call it omega-3, omega-6 sometimes. Okay, so it's animal lipids. So how about plant lipids? I'm going to remove here. Plant lipids. you have a different category also. Number one, lots of you know soybean oil. Okay, where they comes from? Come from seed. Is that right? The soybean seed. Sometimes you have the olive oil. You use dipping. Some of the food products like hams, turkey breast. What is that one come from? That's from coat, plant coat. The last one, you have a coconut oil. So where does that come from? That's from a canal. So let's have a different resource of the plant lipids. Okay, so these are some of the opening remarks, and we will mention these later on one by one. But here is just give you an overall impression of what are the lipids looks like and how they categorize it. Now, since lipids have fatty acids and triglycerides, so we're going to talk about the fatty acids first. So this will be, well, I'll keep these, but then we're going to mention about right here. Okay, so we talk about fatty acids. So first thing first, fatty acids, it is usually, we talk about natural fatty acids. Most of them are saturated. That is 14 to 24 carbon. And with 16 to 18 carbon is dominant. Now, of course, for the natural fatty acids, there is a different categories, like saturated versus unsaturated, which means there is no double bonds. And here you have a double bonds, and the double bonds could be in the same direction, we call it a cis, or in the opposite direction, we call it a trans. Okay, now this is the first thing. Second, based on the chain of the carbon, okay, based on the chain of the carbon hydro, we can see the carbon hydro chain. This is carbon hydro chain, basically is CH2, a very long chain. We could be categorize them onto short chain fatty acids. So that is usually 6 to 10. Okay, median chain fatty acids. That is usually 12 to like 14. How about long chain? Now, long chain fatty acids usually 16 to 24. Okay, now we want to also mention most of the natural fatty acids, that is even number. Because when they synthesize, they always add 2 at a time. So very easy, they are adding 2 carbon each time during synthesis. Then you're going to ask me, how about all the number? This is very rare in natural fatty acids. Most of the time, there's 2 types of the stuff has odd number, which is bacteria, microorganism, and sometimes it's dairy products. Because dairy products is the products of the reacted with ruminant nutrition, the rumen microorganism with the cow. Okay, so lots of them are even number. Okay, when we finish about here, we want to give you some of the examples of fatty acids. Okay, so first of all, we gave you some of the example of the fatty acids, and we are talk about some of the other things, some of the a little bit of confusing stuff there. First of all, we need to know there is some very short chain fatty acids. what are they? What are the simplest fatty acids? HCOOH. What is that? Formic acid. Where do formic acids come from? Antivenom. This is usually the protection. It's like a toxication material for the enemies. They're protected by themselves. Okay, let's make a little bit complicated. This is the first one. Second one. CH3COOH. This is carboxy. And we'll mention it later on. What is this? Acetic acid. Okay, what is acetic acid? Using a vinegar, we have acetic acid. Of course, it's antimicrobial. So 5% will be a vinegar. This is the second example. Okay, then the third example. Let's make a little bit long. CH3, CH2, COOH. What is this guy? Propionic acids. Then, what is that? So where it comes from? This is come from a bacteria called propionic acids. But propionic bacteria. Bacterium. R-I-U-M. Where they come from? If you have a Swiss cheese, you see these holes, it's carbon dioxide. That's going through the fermentation. Okay, they generate propionic acids. That's why Swiss cheese have a very special taste. Okay, number 4. Let's make sure a little bit complicated. CH2, 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 COOH. What is that? Butyric acid. Okay, what is that for? Butter fat. When you have a butter holding you bread, that is butyric acids. And where it comes from? It's a very strong aroma for dairy products. Dairy foods. Now, lots of the people doing the nutrition stuff, if this guy is gone, become a sodium, okay, then that will be a functional foods. Because the sodium butyric acids, lots of people see it is antioxidants, it is nutrition stuff, it is will be triggers the formation of the bone formation, absorb the calcium, lots of the research done for that. So here I give you some of the examples from formic acids, acetic acids, propionic acids, and butyric acids. Then the chain will become long and long, long and long. You see, like so long. So what we should do then there's a problem. This is so long chain, when you add CH2, which is a carbon hydrogen, become long and long, long and long. What we have to do? Then we have to, yes, thank you, we have to talk about how we're going to name them. Is that right? So, therefore, we're going to have a next topic. How are we going to name fatty acids? Of course, including saturated and unsaturated. Now we have a terminology for that, which is called nomenclature. So nomenclature of fatty acids. Now the nomenclature fatty acids, there is 2 methods we can use. There is one method widely used in the chemistry area, which is established by, we call it, right here, called International Union of Pure and Applied chemists. So we call it IUPAC. There is IUPAC standards to name the different fatty acids. They have a 3 different numbers. The first number we call it a systematic number. The second one we call it a common name. And the last one we call it a numerical abbreviations. Abbreviation. So it looks like a little bit complicated. So we give you some of the examples. There is a table talk about that. Let's say capric acid. We put numerical abbreviation is C10-0. Okay, what is a systematic number for that? Deconic. So we want to talk about these. First of all, what does this mean? Capric acid is a common name. It's a chemical name. We need a common name because not everybody is chemistry professional. So we have it. What does C10-0 means? This is a 10 carbon. No double bonds. Very simple. So it's a saturated fatty acids. Then when we come to here, what is decone? Here, we should always call it DECONE. Then we become OIC. Here, this terminal E becomes OIC. Okay, because it is an acid. And OIC, which means you have this ends. What is this end? Carboxy end. That's why we call it like that. Okay, I'm gonna skip some. Introduce you something very common. The very common saturated fatty acids is most everybody knows is C16-0. What is this called? That is 60 carbon and no double bonds. Saturated fatty acids. What's the name of this one? What's the common name of this one? So I'm going to remove this. What is the common name of this one? Palmitic acids. Not very good, to be honest. All the foods have it. Saturated fatty acids. Don't eat too much about that one. You're going to become very fat and overweight. Palmitic acids. Where they come from? Palm oil. Palm Beach, Florida. The name where they come from. Palmitic acids. So what are you going to name it? Hexadecanoic. Okay, another one. Everybody knows. C18-0. Which means it's 18 carbon and no double bonds. Saturated fatty acids. What is that one? Stearic acids. Yeah, everywhere. Pork, beef. Then how we name it? Octadecanoic. Okay, that's a systematic number. So we finished talking about these major saturated fatty acids, how we name it. How about the unsaturated fatty acids? We want to talk several. Okay, first of all, C8-1 delta 9. This has become a little bit complicated. What this means? 60 carbon, 1 double bonds, and 9 carbon distance to carboxyl end. Okay, that's carboxyl end. So that means it's the end is this guy. Okay, right here. So what is that? Oleic acids. Okay, how are you going to name that one then? Decyl-onic. At this moment, decocyl-onic. At this moment, this A becomes E. When you have this E, which means it's unsaturated fatty acids. Okay, I need to double check. This spelling is good. Octodecyonic acid, sorry. Decyonic. This A becomes an E. Okay, this is A here. This is E. When you have an E there, replace A with E, which means it's unsaturated fatty acids as a double bond there. So oleic acids. Okay, let's give another example, a little bit complicated. C18 to delta 9. What does this mean? 60 carbon, 2 double bonds. And the first one, okay, remember the first one is 9 carbon distance from carboxy ends. So what is that? Linoleic acids. Okay, how are you going to name it? Octodecodianic.
Wait, if it has 2 double bonds, where's the second one?
I'll talk real quick.
Okay.
I'll show you real quick. Okay. I'll show you real quick. That's a very good question. Okay. Let's give an example. Another example. C18, 3, delta 9. And you can do it. What is that? Linolenic acids. So how you name it? Octodecotrianic. Is that right? Okay. Michelle have a question. That's a very good question we want to mention. Make sure it's covered in the area. When we name here, this is all come from is a carboxy end. There is another name which is from called omega system. This omega system is coming from where? It's coming from meso ends. Okay, so we gave you an example, and I will mention that. We'll give you an example. You all see, sometimes right, C18, 2N6. What is that? Linoleic acids. Same thing. How we do it? CH3 1, 2, 3. Okay, let's do that. Carboxy ends. This is meso end. Okay, let's count. From carboxy end, this is carbon number 1, number 2, 3, 4, 5, 6, 5, 6, 7, 8, and 9. Okay, then how you do? 10, 11, 12, 13. So, Michelle, answer your question. The second one is right here. Start from carbon 12.
Well, I've just always seen, like, for example, on linoleic, it would be C18 delta 9, comma 12. Like,
Yeah,
put the-
that's carbon 12. Some people put 12 there. Yes,
Oh,
yes,
okay.
you're right. Some people put 12, some people only write the first one because they always is interrupted. That's a very good question. It always interrupted with a methyl group. Okay, so this is what I'm talking about right here. What's the omega 6 system? You heard about omega 3, omega 6 all the time. There's some advertisements say you drink some of them, eat some of them. You're good for the health. So what are they? They're coming from is a methyl end. Okay, so let's do another label. This is carbon number 1, 2, 3, 4, 5, and 6. So what that means? This is 18 carbon have 2 double bonds. The first one is 6 carbon distance from the methyl ends. So this is number 1. So what is this called? Omega 6, this is called. This is linoleic acids, actually. Okay, then we give you another example. C18, 3 and 3. This is what we call omega 3. Then what's that? Let's do it again. C3, one, two, three. Carbon number 1, carbon number 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Can you see it? So what does that mean? This is 18 carbon have 3 double bonds. The first one is 3 carbon distance from the methyl ends. From the methyl end. Now they come to have question. Why they do omega 6 system name? Why the nomenclature system they use omega system? Because it's from biological activity standpoint. These other position is all recognized by some of the enzymes, and they can work with the enzymes and then generate a biological activity which is decrease the blood glucose. That's why they grouped them into omega 3 and omega 6. Okay, so you can go back to see here. You can, if you're interested, you can do by yourself, the EPA and DHA. Isocapentaionic, docosahexaenic, you can figure out that. Every time it is all 3, except this one, sometimes people write 19. It's all 3 carbon distance. Because of this. It's all 3 carbon distance. The double bond is always 3 carbon distance. Okay? So that's why I want to spend in time talk about here is about the name system, how we do the nomenclature system for these fatty acids. Now in our textbook, we want to make sure your life is a little bit easy because it's a food chemistry class. It's not really an organic chemistry class. So in our textbook, we did a little bit easy for you. We call it shorthand description. That makes your life much easy. For example, this one you know, stearic acid. 60 palmitic acid. And 8,1,C9, this is oleic acid. You can give all the examples. This is called a shorthand description. Makes your life a little bit easy to understand. Because from the food chemistry standpoint, they're manufacturing this stuff. Don't want to be make it too complicated. Okay, so that's why they come out with this easy system to let you understand about that. Okay, so this is something I want to mention. Now the next one, what I want to mention is we can just move back right here. We want to mention a very, give you an introduction of a very simple, but it's always got to mention about the characteristics, which is called melting points. This is a major characteristics for fatty acids. We talk about the melting points. MELT. So melting points, we will mention that all the time in the section. There is a conclusion we can give right here. So I'll write low and write high. So let's compare. Let's say the first comparison is saturated fatty acids with unsaturated fatty acids. Now, of course, saturated fatty acids is in the high category, and unsaturated fatty acids is in the low category. Okay, this has a double bond. This is no double bond. The second example is, we had a long chain saturated fatty acids and a short chain. Now, of course, the long chain has a high melting points, and the short chain has a lower melting points. That's easy to understand because you have those carbons, so many carbons to need to be melted or hydrolyzed or whatever you call it. The next one is, we talk about cis and trans, and most of the time is trans fatty acids has a higher melting points compared to the cis. Now here we want to talk a little bit more. Why the saturated fatty acids have a high melting point compared to the unsaturated fatty acids? The first reason is, when you have this double bond, you create a curvature, sometimes called kink, a curvature during the carbohydrate bonds. So the carbohydrate bonds will be difficult to align together to generate crystallines. So that's why it is going to be lower, because there's no crystallines. And crystallines we don't want to generate because it's organized. Once it's generated, you need a higher energy to break down. That's why the melting point is higher, the melting temperature is higher. So when you have this curvature there, it is difficult to generate a crystallines. That's why it's lower. But how about cis and trans? These trans fatty acids, you will become linear. Very linear. So once it becomes a very linear, what happened? The crystalline will be generated. Very easy to have a crystalline. So again, the strong crystal structure there will let the melting points is higher. Now we want to mention and do a little bit of review how this comes from cis to trans. How they do it. So we give you a very simple example. Okay, oleic acids. Oleic acids, how we do it? 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. Should have another one, because that's from 9. Should have another one. CH3. Okay. 2, 3, 4, 5, 6, 7, 8. Let me see. This should have another 2, 3, 4, 5, 6, 7, 8, 9. Okay, sure. Sorry. This should be put down. Right here. Right here. Two, 3, 4, 5, 6, 7, 8, 9. Okay. 2, 3, 4, 5, 6, 7, 8, and 9. That's double bonds or down. Then you have 10, 11, 12, 13, 14, 15, 16, and you should have one more. Go down here. That's become 18. So go down here. 17. And this is, that's oleic acids. Oleic acids, if we going through a process called hydrogenation, we mentioned it one time, M-A-T-I-O-N, hydrogenation. Okay, what is hydrogenation? In a closed vessel, closed vessels, we're gonna be bubbling H2, and then we're using heat, 200 degrees Celsius. And we need a catalyst with a nickel. So we do a hydrogenation. We're going to add hydrogen there. However, when you try to add a hydrogen there is a problem going to generate because originally they don't have it. And you add it. So there's a little bit of resistance. We call it a chemical immunology. What I said, the chemical immune. And then there will be the first places when they have the carbon, the double bonds. They were very easy to become trans configuration. Okay, so when they become a trans configuration, what is that? This is go down. Okay, this bond is up right here. This bond is go down here. There you go. Same. What is this count? Electric acids. That will become a trans now. Okay, then become an electric acid. Usually the first carbon is twisted a little bit to become a trans, because the configuration changed. Now, who found this one? When they find it? As early as 19th, originally they are trying to make a soap. When they manufacture a soap process, they find the trans fatty acids comes out. Those fatty acids are very tough and have a very high melting point. Later on in the 1980s, that is what is dominant. In the bread manufacturing, people find that the trans fatty acids, if the bread has trans fatty acids, it's a very long shelf life because it's prevent. We call the lipids oxidation and have a terminology called rancidity. Now, especially remember the curve. If you still remember this curve, we talk about, if you always remember this curve, where's happened? The lipids right here. In the monolayer, which is a lower water activity range. So for bread, it's like dry food. What's the median dry food? The lipids oxidation, the rancidity is very easy to have. If you have it put on the bench, about a couple of weeks, you taste it, it's like a sweetness comes out. It looks very sweet, that's right, rancidity. In 1980s, when people find the bread, if they have a trans fatty acid, it's a very long shelf life because it's prevent lipids oxidation. So they start to generate, and then when you have a margarine and the shortenings, all those products comes out, it's all has trans fatty acids. But people find it's not good because the trans fatty acids is not going to be hydrolyzed easy by the liver. And so you accumulate it more and more, will cause a clotting of the blood cell, and then finally will have a cardiovascular disease. But then the question is why people have these products. This is, you should know, in early 80s, we are talking about is food security versus food sustainability. When the time, people not rich, people in the poverty, the security is number one. Those products is cheaper to give them the energy resource to survive. When you become rich, your life is good, then you start to think about affordable, safe, and nutrition food. So it's a different level. During the development of the food chemistry and the food manufacturing, the whole science, these products really gives you some of the food security. So that's their contribution. But later on, people really recognize it's not very good. Okay, so that is a trans fatty acids. We will mention this later on again. Okay, then the next one, what I want to mention is that we finished talking about these sections. Then we want to talk about is triglycerols. And we'll talk about more on Thursday, but I want to give you some of the